Hi, and welcome to Hacker 101. In this session, we're going to go over some basics of the course, what you're going to learn, tools of the trade, some breaker philosophy, and our very first vulnerability. Let's dive in. I'm Cody Brocious, a researcher with HackerOne, and I'll be your instructor throughout the class. Here's what you'll learn: how to identify, exploit, and remediate the top web security vulnerabilities, as well as many arcane bugs, how to properly handle crypto, how to design and review applications from a security standpoint, how to operate as a bug bounty hunter or a security consultant, and much, much more. To get started, you don't need to be on any particular OS, but I do recommend that you have the ability to run Java applications. This is essential for one of the tools we'll talk about in just a moment. I also recommend that you brush up on your web request skills. You'll often find cases where you want to automate some number of requests. Being able to write such scripts quickly and effectively is a really important skill to have. My personal favorite library for this is the requests package for Python. It makes such scripts trivial in most cases. There are two, in my opinion, must-have tools for this kind of work: Burp Proxy and Firefox. Burp Proxy lets you monitor and tamper with HTTP and HTTPS traffic. While alternatives do exist and will work just fine for this class, Burp is really the industry standard. The free edition is just fine for our purposes, but I really do recommend the pro version when you start using this in practice. It's not super cheap, but it's well worth every cent. And the reason I recommend Firefox over other browsers when it comes to this kind of testing is that you can trivially set proxy settings just for it, rather than your whole system. This means that you can get just the traffic you care about, rather than seeing all the web traffic for your system. It also includes really nice developer tools, letting you view and manipulate cookies, browse the DOM, etc. As with Burp, it's entirely possible to use alternatives. Chrome will work just fine, but I personally find Firefox to be the best choice for these tasks. Now let's switch gears and talk a little bit about the breaker mindset and some more philosophical things. Your goal in this class is to break things before others can. This means you need to stop thinking like a defender and start thinking like an attacker. You need to know how attackers operate, what their goals are, and how they think. If you can do that, you'll win. One of the things I like to impress upon people is this: pushing a button is the fastest way to figure out what it does. As such, going through an application and pushing every single button will help you understand what the application does, how it does it, and how it may break down. And another thing I'd like to keep in mind is that there's an inherent imbalance between the burdens on attackers and defenders. Generally speaking, defenders have to find every bug, while attackers only have to find a small, finite number of them, often one. This means that attackers always have a distinct advantage over defenders. In practice, the primary consequence of this is simple: you will never find every bug. This is especially true because in the real world, you don't have an infinite amount of time or attention to dedicate to everything you want to break. What that means is that prioritizing your efforts is critical. Particularly, you need to determine areas of higher risk so that your time gives the biggest reduction in attack impact or likelihood. As such, assessing what an attacker may actually want is one of the most important skills that you can build. The first step is to figure out what functionality exists. Then, for each function, consider what an attacker's goal would be in compromising that. For instance, if it's an e-commerce site, then perhaps the primary goal would be credit card numbers. If it's a server monitoring app, I might want to destroy or even falsify data. Once you've got this, you can prioritize. You can rank the areas of the application based on where the highest payoff will come from. If I compromise X, does that give me low value or high value information? What if I compromise Y instead? If you're able to chat with the developers, ask them what keeps them up at night. This will often give you a fair idea of where to look. Now let's discuss reporting. This is a critical skill, as communicating with developers, clients, and other hackers will affect the value of your findings more than almost anything else. For the purposes of this course, and for most bug reporting you'll do in general, you're going to want to include the following for each bug: a title, severity, description of the bug, steps to reproduce it, the security impact, a mitigation, and a list of affected URLs. Severity is subjective and it's handled differently everywhere, but this is approximately what I use. Informational: the issue has no real security impact, but it could in the future. Low: the business impact is minimal. Medium: there is a potential to cause real harm to users or the business, but not revealing any critical data. High: potential to reveal user data or aids in exploitation of other important vulnerabilities. And critical, high risk of personal or confidential data exposure, general system compromise, or other situations with severe business impact. Now, finally, let's take a look at our very first bug. Take a moment to pause and look over this very contrived example code and wrap your head around what it's doing. The code is pretty straightforward. If a name parameter was passed over get, print hello name in an h1 tag. Then print a form for the user to enter a name. What could possibly go wrong with such simple code? Well, what if you went to the URL on screen? There, we're saying our name contains a script tag. That would get echoed right into the HTML. What you've just seen is an example of reflected cross-site scripting, one of the most common vulnerabilities out there. This occurs when user input is sent directly back without sanitization or encoding. As a result, an attacker can use this to make a victim's browser run any JavaScript code in the context of their account, letting the attacker perform anything the user can. This is, as I said, a contrived example. We'll cover way more about XSS soon, but think about how often you see input reflected. For instance, go to Google and search for something. How many times does your query end up reflected on the page? Imagine the impact if even one instance was vulnerable. Now, a quick bit of wrap up. In the next session, we're going to be talking about how browsers and the web work in depth. You'll also learn about cross-site request forgery, a very common vulnerability with high impact. Until then, get your proxy set up and play around with it. Start browsing the web through this proxy and watch the flow of data. I also recommend checking out your own sites if you have some, and pay attention to where input gets reflected. Thanks so much for watching, and happy breaking!